So now you've had a little bit of introduction to the periodic table, and now we're going to look at periodic law. This is basically how is the periodic table laid out. In the first video that you watched today, you saw that the information that was inside one of those blocks and where we get that information from. But how is the whole thing laid out and in the order that it's in? So the periodic law states that certain chemical and physical properties, the characteristics of the element, those repeat themselves every 8 elements when the elements are arranged in order of increasing atomic number. And so you'll see this really clearly on the second and the third period or row going right to left. If you start with lithium, so you said there's 1 electron on the outer ring, then go over to group 2, there's 2. Then it gets a little confusing because you're going to skip that middle section there for what we're doing and go to group 13. So group 1 has characteristics, group 2 has characteristics, 13, 14, 15, 16, 17, 18, and then it starts back over at group 1. So all it's saying is that there's a pattern that's happening here. So when we look at the organization of the periodic table, there's 2 things to kind of look at and notice of how they're organized. This blue box you see here, this is the periods. This is how they repeat. And then you see up and down in this red box, this is the family. So the periods are when they repeat. The families share characteristics or qualities with one another. They're organized by their atomic number. So hydrogen is 1, helium's 2, lithium's 3, and so on. But you see them, you need to know period is left to right, side to side. Group or family, the names are interchangeable, are up and down. Remember, groups and families have similar characteristics, just like a biological family. A family of people would have certain characteristics, or an animal group or family would have certain characteristics in common. Elements that are the same group and family have certain characteristics that are in common with one another. So groups and families have a similar reactivity. They're organized by atomic number. They're also organized by reactivity. So this is one of those characteristics that repeats itself. Reactivity just means how well it bonds with other things, how well it reacts with other chemicals or elements. So you see group 1, they're metals that react violently with water. So they have a big reaction when they come into contact with water. On the other end, all the way to the end, group 18, they're gases that barely react at all with anything. So group 1, very reactive with the exception of hydrogen. They're all metals. Group 18, they're all gases called the noble gases, and they barely react to anything. So they're grouped by similar reactivity, which is determined by their electrons. So here's some definitions of properties. Elements are in the same group have these similar properties. Chemical properties describes how a substance will react with another substance. How does it bond together? What are the reactions that take place? Is it explosive? Does it catch on fire? Does it rust? These are chemical properties. Physical properties describe the physical characteristics of substances and elements. Is it hard to the touch? Does it have similar a color or a sheen? Is it shiny? Is it dull? These are physical properties that define what kind of element it is and what family it belongs in. So why do groups react the same way? I said a minute ago, this is based on their electrons, specifically the valence electrons. Valence electrons are the electrons that are on the outer energy level and available for bonding. So if you look in group 1, each one of those has 1 electron on its outer energy level. So they have the same number of valence electrons. When you look in group 18, all but helium have 8 on their outer electron. So the same number of valence electrons. Helium's there as well. It only has 2, but on the first ring, 2 fills it all the way up. So it fits the characteristics of those noble gases. And same thing, if you look at group 2, all of them have 2. If you look at group 13, they all have 3. That gets a little confusing because the name of the group changes as far as how many valence electrons it has. But just remember 1 and 2 have 1 and 2. 13 through 18 have 3 through 8 valence electrons, those electrons on the outer energy level. Now, elements have an octet rule. Atoms tend to gain, lose, or share one or more of their valence electrons to achieve a filled outer electron shell. So that group 1, they are quick to lose an electron because they want a filled outer shell. Group 17, they're quick to take an extra electron because they want a filled outer shell. This is how atoms bond with one another. So if you look at those electrons orbiting in shells, you see sodium here has 3 shells. The most electrons that can go in the first shell is 2. So at 2, it fills up and it needs another orbital shell. And so that one fills up at 8 and it needs another. And so that one fills up with, or doesn't fill up, but finishes out with 1 because sodium has 11 electrons. And so there's 1 that's going around on that outer shell. That 1 is the one that's going to determine how it bonds. So if you look at electrons, orbits, and shells, you see first shell can fit 2, as we just said. Second and third can both fit 8. That's as far as we're going to go in this class looking at that. And so if you remember the first shell fits 2, the second and third shell can both fit up to 8, you're going to be in good shape for this class. And so there gives you some examples of what those look like. So here's some questions for you to go through in this one. How many electrons does oxygen have? So you have to look at your periodic table, remember back to how you figured that out, and how many electrons does it have? So how many electrons are in oxygen's outer shell? Remember, 2 can go on the first, up to 8 on the second and third. So how many are going to be on that outer shell for oxygen? Which group is oxygen most likely to react with? So you have to find what group it's in, how many electrons are on its outer shell, and then which group has the number of valence electrons that could add together with oxygen to make 8 on that outer shell. If you're confused by that, make sure you're asking questions and pausing. Take a minute, go ahead, pause the video, figure out the answers to those questions before you go on. Here's some more questions. Only use the first 3 periods, only use the first 3 periods for these questions. So for the first 3 periods, remember the periods are those left to right rows. How many electrons are in the outer shell of each element in group 1? What about group 2? 13, 14, 15, 16, 17, 18. Talked about this just a second ago. Can you remember? How many electrons does each element in each group above need to fill its electron shell or its outer shell? Which groups are the most likely to react with one another? And which group is least likely to react with any other group? Take a minute, pause the video, see if you can answer those questions. If you're not sure, ask a teacher. So here's the take-home message. This is the big ideas from today from these first 2 videos. The properties of an element can be predicted from its location on the periodic table. If you know where it is on the table, you know how it's going to react with things. And this is largely the result of the number of electrons on their outer shell. Make sure you get down the notes that you need from today. We'll be doing some more of these video lectures for you to continue to fill out your notes in this unit. But make sure you get down everything you need for today. If you have questions, ask. Make sure you're not just kind of going out there assuming you know the stuff when you may not actually know it. So take the time, do the practice, ask the questions, and then move on with the next activity in this assignment.